Alright, this is video 2 for the mechanics unit notes. In this one we're going to talk about rotational motion. Rotational motion happens when you have something spinning around an axle or an axis, such as a wheel, which for robotics, that's quite a lot of things. We could also have an arm, so if we have some sort of structure that is spinning, like turning around, so maybe you have an arm like a little claw on it or something. That would be rotational motion as well. When we discussed linear motion, we used inches, feet, meters, things like that. And we use that to measure position, distance, displacement. Now for rotational motion, we're going to use something called the radian. So to calculate the radian, what it is we have, instead of linear positions, we have angular positions. So the radian, which is represented with theta, is equal to the arc length s divided by the radius r. And the unit for it, now notice that this would be meters divided by meters or feet divided by feet. So this is a ratio. So it's unitless. So we give it a value, or we just call it radians. Now this does lead us to something called the unit circle. Notice in the unit circle that when we go counterclockwise, it's positive, and if we go clockwise, it's negative. And a full rotation is 2 pi radians. There's also degrees, so a full rotation is 360 degrees, but it's better to use radians. However, sometimes we want to go back and forth. We want to convert between them. So notice that 180 degrees is the same thing as pi radians. So what this means then is that the degree times pi over 180 equals a radian. And likewise, the radian times 180 over pi, that equals to the degree. The math is exactly the same as it was with the linear kinematics. What happens is that the x becomes theta, the v becomes omega, lowercase omega, and the a becomes alpha. But everything else is the same. We have something spinning at a constant rate. If omega is constant, that means it's spinning, but it's not speeding up or slowing down, then alpha will equal 0. So everything else is exactly the same. We do have some bridges between the two. Linear speed equals radius times angular speed, so v equals r times omega. And also, acceleration equals r times alpha. So we do have those two bridges between rotational and linear. All right, I think that will finish up video 2. Kind of a shorter video, but the mathematics are so close to being the same that it's almost not even worth mentioning. Everything mathematically is identical. All right, that finishes up this video.